Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve another GATE question. This question was asked in the year 2005 for 2 marks, right? So this question is related to the fork system call. So let's read this question. So the question goes something like this. Consider the following code fragment, right? This is the code that they're talking about. Let u and v be the values printed by the parent process and x and y be the values printed by the child process, right? So basically, this is a code snippet, and as you can see, there is a fork system call. And when the fork system call will be executed, there will be basically a parent and a child process. A new process will be created. So as you can see, there are some printf statements. So this printf statement, as you can see, is printing two values. So in case of the parent process, we are assuming that it is u and v. In case of the child process, this value is named as x and y. So what is this question asking? The question is saying which one of the following is true. So basically, we have to find the relation between u, v, x, and y. These values u and v are the values printed by the parent process. The values x and y are the values printed by the child process. So now you have to find out the relationship between u, v, x, and y, right? So let's see how we will solve this question. So now let us solve this question. So I have written down all the pieces of information, the relevant pieces of information that we have. This is the piece of code that we have to execute. The key points here is that the values that are printed by the parent process, that is u and v, whereas the values that will be printed by the child process, that is x and y. And we have to find the relation between u, v, x, and y, right? So before we execute that code, let us recall how the fork system call works. So I will only give a brief recall. I have discussed the fork system call in great detail in another video. So at a very high level, what does the fork system call do? It creates a new process. And how does it create a new process? It creates a new process by duplicating the calling process or the original process, right? So here in this example, as you can see, we have a process A, right? And somewhere within the code of process A, there is this invocation to the fork system call, right? So when this fork system call is executed, what happens is that the control is immediately transferred to the operating system. So the control will be transferred to the fork routine, which is defined inside the code base of the operating system, right? Like any system call, whenever we make a system call, the control is transferred immediately from the user process to the appropriate routine inside the operating system's code base, right? So now the operating system is executing, and when this fork system call routine will be executed, what will happen is that a copy of this process will be created, right? So here you can see we have a new process, that is process B, and process B is the child process of process A. The process A is the parent process B is the newly created process or the child process. And as we know, the new process that is created, that is process B, it is almost an exact copy of the process A. So when we say almost an exact copy, we mean that the code, everything is same. The code that will be executed by process B, the data that will be processed by process B, everything is the same as process A. Only a few pieces of information like the process ID of process A and process B will be different. Some other minor pieces of information are different. Rest, everything is the same in process B or the child process, right? So once the fork system call has done, it will return. And how does it return? As we know, the fork system call returns twice. First in the parent process and another time in the child process. So since the parent process was the one which invoked the fork system call, obviously it will return there. But it also returns in case of child process. And in both the cases, the execution starts from the statement which follows the fork system call. So as you can see, here in the parent as well as the child, this is the fork system call, and the control, basically when the fork system call returns, it is returning to the statement which follows the fork system call. So from there on, the execution will proceed, right? Another important thing is the value that is returned by the fork system call. As you can see, the fork system call returns different values in the parent as well as the child process. So what are the values that it returns? In case of the parent process, the value which is returned by the fork system call, it is the PID or the process ID of the child process. And in case of the child process, the fork returns the value of 0, right? It's a special value that is 0. So let's assume that in this case, the process ID of process B, which is the child process, it is 100, right? So the process ID of process B will be returned to the parent. As you can see, the value 100. Again, this is a hypothetical example. We are assuming that the process ID of the child process is 100, and that is what will be returned to the parent process, right? And in case of the child process, this value which is returned is 0. So why do we have different return values? This is because we can check this value and determine whether we are in the child process or in the parent process, because the same piece of code is executing, right? So by checking this return value, this gives us a way to distinguish between whether we are in the parent process or in the child process. If the value is 0, then we know we are currently executing in the child process. If it is non-zero, then we can be sure that we are executing in the parent process, right? So this was a brief recall of the fork system call. So now let's execute this piece of code, right? So this is the process, the parent process, and we are basically now concerned with the process address space of the parent process, right? So this is the piece of code. Let's look what is happening here. So there is a if else branch, right? In the if branch, we are checking the condition. Basically, we are first of all invoking the fork system call, right? And whatever value is returned by the fork system call, that value we are checking whether it is 0 or not, right? If it is 0, then we can be sure that we are currently in the child process. So this if branch, this will be executed by the child process, right? And if it is non-zero, then we will go to the else branch, and the else branch will be executed by the parent process. And what is happening in these branches? Basically, there is some variable a, right? Some integer value a, and we do not know what is the value of a, right? It could be anything. And in the child process, we are adding 5 to a and printing the value of a as well as the address of a, right? The value of a as well as the memory address of a. So this %p specifier is used to print memory addresses, right? Whereas in the case of the parent process, what we are doing, we are subtracting the value of 5 from the value a. In the case of the child process, we are adding 5. In case of parent process, we are subtracting 5, right? And again, in both the cases, the printf statement is the same. We print the value of a as well as the memory address of a, right? So this is a description of the code, and as you can see, this is the address space. So this variable a, it's an integer variable. I have placed it on the data section, right? It could be on the stack section also. It could be on the heap section also. That is kind of immaterial. Just for the sake of simplicity, I have placed it on the data section, right? So this variable a, it is defined at some memory location, let's say 0xFFFF. It's a random hypothetical location that I'm assuming, right? So this is the basic setup. This is the parent process address space, the process address space of the parent process, right? So now let's execute this piece of code and see how the execution happens. So first thing that will happen is the fork system call. And when that happens, a copy of the parent process will be created. And so the process address space will also be copied, right? So as you can see, here is the child process. The same code will be executed by the child process. The code, everything is the same, right? So you can see the process address space of the child process is identical to that of the parent process. Here also the variable a is there. We do not know what is the value of a. We are just assuming some variable a with the value, right? So it is again defined at the same location, that is FFFF. These are virtual addresses, right? These are virtual addresses which are part of the process address space. So in both the address spaces, right, the variable a is present at the same location and it will have the same value, because this is created by copying this, by duplicating this process address space, right? So now, as you can see, basically what will happen after the fork system call? When the fork system call returns, it will return a value. In case of the parent process, it will return the process ID of the child process. And let's just assume that the process ID of the child process is 100. So in the parent process, this value that will be returned will be 100. In the child process, it will be 0. So in the child process, this if condition will be true, that is 0 is equal to 0, and this if branch will be executed, right? Whereas the else branch will not be executed. Whereas in the parent process, this condition will be false, that is 100. Whatever is the process ID of the child process, it's a non-zero value. This won't be equal to 0. This if part won't be executed, and in the parent, the else part will be executed, right? So as you can see, this is a mutually exclusive kind of thing. So in the case of the parent, this else part will be executed, the if will be skipped. In the child process, the if part will be executed, the else part will be skipped. So this allows us to perform different tasks in the parent and the child process. Even though the code is same for parent and the child, nonetheless, we are doing different things in the parent and the child depending on the return value, right? So this is how the different return values that fork returns is useful, right? It helps us to identify that in which process we are currently in, whether in the parent or the child, and depending on that we can perform different tasks, right? So now let's execute these statements. So as you can see in the parent process, the value of a has changed to a minus 5. We are not concerned with the actual value of a. Whatever is the value of a, that will be basically that will decrease by 5. And in case of the child process, it will increase by 5. So before executing these statements, it was a and a in both parent and child. After these statements are executed, in the parent it becomes a minus 5, and in the child it becomes a plus 5, right? So the value of a changes. Okay, so now let's print the statements. Let's execute the printf statements. So the printf statements are the same both in the parent and the child. So what are we printing? We are printing the value of a, and then we are printing the address. So in this case, this is how the values will look like. So as you know, we had assigned different variable names to the different values that will be printed. In case of the parent process, we have u and v, and in case of the child process, we have x and y. So whatever is the value of a, we have assigned that to u. Then the address is v. In case of the child process, the value of a is assigned x, and the address of a is assigned y, right? So as you can see, in the case of parent process, we are printing a minus 5. In case of child process, we are printing a plus 5, and the memory address of both, basically the memory address of variable a remains the same both in the parent as well as the child process, because both the process address spaces are identical, and the variable a is present at the same location in both these address spaces, right? So now we have the values of u, v, x, and y, and we can find the relation between u, v, x, and y. So which of the following is true? Basically, as you can observe, v and y are same. V and y are the memory address of the variable a. So v is equals to y. So option B and option D are wrong, obviously, because b is not is equals to y in these options. So out of option A and option C, which one is true? Option C is true, because as you can see, u plus 10 is equals to x is true. So u, if you add 10 to this, so a minus 5 plus 10 will become a plus 5. So u plus 10 is the same as x. So this option C is correct. That is u plus 10 is equals to x and v is equals to y, right? So we have figured out the relationship between u, v, x, and y. So what I will do, I will also show the actual code. I will show what is the values when we execute the actual code. That will give us more clarity. So let's quickly execute the code also to get better clarity about the output that we will get from the piece of from the example code that we had in the question. So I have the same piece of code. I have just annotated basically these strings, that is child, x, y, parent, uv. Basically the question that we had there, we are just printing the value. I am also printing whether we are in the child process or in the parent process, and the values x, y, uv I have annotated to the printf statements, right? Also, I have initialized the value of a as 35. I have made it a global variable, right? We can have it in the inside the main function also. That does not make a difference. So let's execute this piece of code. So as you can see, the initial value of a I have given as 35, right? So in case of the child process, this value should become 40, right? And in case of the parent process, it should become 30. So let's execute this. So as you can see, the name of the file is fork_gate.c. And after executing this, this is the output that we have. So in case of parent, as I discussed, the value that is printed is 30. So initial value of a was 35. In parent, we subtracted 5 from it, so it becomes 30. And in case of the child, which is here, we are adding 5 to this, so it becomes 40. And the memory address that is printed, that is, you can say, is the same, 55615B00010. It is the same in both the cases. So this you can verify that whatever we just discussed holds true. Let me quickly change this value. Let me make this 0, and again let's execute this piece of code. So again, you can see in case of parent, this value becomes -5. In case of child, it becomes +5, and there's a difference of 10 between the value of parent and the child, right? So we can be sure that what we have, the relationship that we have identified is correct, right? So guys, the correct option is option C, that is u plus 10 is equals to x and b is equals to y. So this was it for this question. In this question, we saw how when we duplicate the parent process to create the child process, how the process address space is duplicated, right? The position of the variables, the value of the variables, all the data objects, everything remains the same. And how the return value of fork, right, that is different in the parent and the child process. In case of the parent, a non-zero value, that is the process ID of the child process, is returned, whereas in the case of the child process, the fork returns 0. And then we can check that value and perform different tasks in the parent and the child process. And you can see once we start modifying the values in parent and child, they are different copies, right? We are working on different copies of variables. So the values that are printed by parent and child are different. They go separate ways. So this is how the fork system call first of all duplicates the parent process to create the child process. And then we can use the return value to perform different tasks in parent and child. And once the execution proceeds, the values in the address spaces will change separately. They are not two different processes, right? They are two different entities. So that is how, when the in this case, when execution proceeded, the value of a was initially same when the copy was made, but eventually the values become different, right? So this is how the fork system call works. So guys, this was it for this video. Thank you very much for watching. I'll see you in the next video. Thank you.